Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of radian measure of angles. So let's start with the problem. So as per the problem, the London Eye is a large Ferris wheel located on the banks of the Thames River. Each sealed and air-conditioned passenger capsule holds about 25 passengers. The diameter of the wheel is 135 meter and the wheel takes about half an hour to complete one revolution. And now we have to answer these four questions for this problem. So let's start with part A. So as per part A, determine the exact angle in radians that a passenger will travel in 5 minutes. Now we are given that the wheel takes about half an hour to complete one revolution. And we know half hour is equivalent to 30 minutes. So that means the wheel takes 30 minutes to complete one revolution. Now we have to find the exact angle in radians, and we know one revolution is equivalent to 360 degrees, but we have to find the answer in radians. So 360 degrees is equivalent to 2 pi. So we can write this as 30 minutes is the time taken to go around the full circle, which is equivalent to 2 pi radians. Now we have to find the exact angle in radians that a passenger will travel in 5 minutes. So let's assume in 5 minutes the passenger travels x radians. And we have to find the value of x. So for that, we can make a proportion equation. So our equation will be using these two pieces of information. So the first will be 22 pi over 30 equals x over 5. So now we have to solve for x. So we'll have to isolate x. So we can isolate x on the right side by cross multiplying 5. So we get 2 pi times 5 over 30 equals x. Now we can simplify this fraction. So in the numerator, 2 pi times 5 is equal to 10 pi. So 10 pi over 30 equals x, which can be reduced to pi over 3, because 10 and 30 can be reduced to 1 over 3. So pi over 3 is equal to x. So that means the final answer for part A is pi over 3 radians. So that's the angle the passenger will travel in 5 minutes. So now we are done with part A. We can analyze part B. Now we have to find how far does a passenger travel in 5 minutes. Now in part A, we found the angle through which the passenger will travel. But in part B, we have to find the distance. And for that, we'll have to use the arc length formula. So let's start with the diagram. So let's assume this point A represents the center of the Ferris wheel and the passenger travels from B to C, and the angle at point A is equal to pi over 3 radians, because that's the angle through which the wheel will rotate in 5 minutes. Now we have to find the arc length from B to C. Now we are also given that the diameter of the wheel is 135 meters. So sides AB and AC represent the radius of the wheel, and we can calculate the radius by dividing the diameter by which is equal to 67.5 meters. Now we can use the formula for arc length, and the formula is theta equals A over R. So in this formula, theta is the central angle in radians, which is equal to pi over 3 equals A over 67.5. Now we can solve for A. So we can cross multiply 67.5 to the left side of the equation. So we get pi over 3 times 67.5 equals A. And now we can evaluate this fraction. So A equals, so we do pi times 67.5 divided by 3, which is equal to 70.7. And the unit is meters, because that's the unit of radius. So this should be the final answer for part B. So now we can analyze part C. So in part C, we have to find how long would it take the passenger to travel 2 radians. So we'll do the same analysis that we did for part A. So in 30 minutes or half hour, the passenger travels 2 pi radians. Now we have to find the time in which same passenger will travel 2 radians. So we can create a proportion equation. So the proportion equation will be 2 pi over 30 equals 2 over t. So now we have to solve for t. So the first step is to cross multiply the denominators to the other sides. So we multiply 2 pi by t. So we get 2 pi t equals 30 times 2, which is equal to 60. And now we can divide both sides by 2 pi. Now the 2 pi's on the left side will get cancelled out. So we get t equals 60 over 2 pi, which can be simplified to 60 divided by, so I got 9.5, and the unit is minutes, because that's the unit of the other time we used in the equation, 30 minutes. So this should be the final answer for part C. Now we can analyze part D. So in part D, we have to find the angular velocity of the passenger in radians per second and degrees per second. Now angular velocity is defined as the angle through which an object moves per unit of time. The formula for angular velocity is W, which is the symbol for angular velocity, equals theta over t. Now we are given that the wheel rotates 1 revolution in half an hour. So that means the theta here will be equal to 2 pi, because that's the radians in 1 full revolution, divided by 30, which is in minutes. Now since we have to find the angular velocity in radians per second, we'll have to convert minutes to seconds. So t is equal to 30 minutes, and we can convert it to seconds by multiplying 30 by 60, which is equal to 1800 seconds. So we'll divide 2 pi by 1800. And we can reduce this fraction by dividing the numerator and the denominator by 2. So in the denominator we get 900. So the angular velocity is pi over 900 radians per second. So this is the exact value of angular velocity. Now the approximate value can be calculated by dividing pi by 900, which is equivalent to 0.0035 radians per second. So I'm rounding the answer to 4 decimal places. Now we can calculate the angular velocity in degrees per second. So for that we can use the same formula, W equals theta over T. Now for degrees, theta will be equal to 360 degrees because one full revolution is equivalent to 360 degrees and the time will be the same, 1800 seconds. And now we can divide these numbers. So 360 divided by 1800 is equal to 0.2 degrees per second. So this is the angular velocity of a passenger in degrees per second. So these are the steps you have to keep in mind to solve a problem like this one. So you have to be very careful with what type of information is given in the problem and how you can use that information to answer the questions. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.